Fuse panels. Edison base screw fuse panels. Edison base fuse panels were universal from the earliest days of electricity in the American home right up to the 1950s when breaker panels started to appear in residential construction. Many homes built up until the late 1960s still had fuse panels. Fuse panels are sometimes mentioned as being more reliable than breaker panels because of the fact that they will always blow when overloaded, either by loads imposed on them or under dead short conditions. And some circuit breakers have been known not to trip at the specified amperages. Many insurance companies, however, will either not insure homes with Edison-based fuse panels or will insure them at higher premiums. This is not due to any danger from the fuses themselves, rather it is indicative of a generally older, unimproved system that statistically is more likely to produce an electrical fire. Fuse blocks. Many fuse-style panels use a fuse block as both the primary overcurrent protection and also as the disconnecting means. These bakelite blocks contain two cartridge or shotgun shell fuses. This block or blocks must be pulled to disconnect the power to the home. These fused panels are normally rated at either 60 or 100 amps. Main and range panels. Many homes from the 1930s onward used main and range panels. These have two fuse blocks, one acting as the main disconnect and primary overcurrent device, and a second block supplying power for the electric ranges. These became very common from this time on. Some fuse panels may contain as many as 4 fuse blocks, commonly having one as the main disconnect, with others supplying other 240-volt circuits for appliances, such as ranges, air conditioning equipment, clothes dryers, and even other distribution or sub-panels. In all cases, all the blocks must be removed to completely disconnect all the power to the home. Edison base or plug fuses. These are the fuses that screw into many older panels and have the same thread that Edison used for other applications such as the common light bulb. This obviously creates a problem, since a higher amperage fuse can be screwed into a location supporting lower amperage conductors, effectively turning the conductor into the fuse. Not a great idea. The inspector should recommend the installation of S-type fuses and adapters to ensure that the circuits cannot be overloaded. These adapters screw into the standard fuse location and reduce the thread size down. Various sizes are available from 15 to 30 amps and allow only the correct amperage type S fuse to be installed. These adapters are designed so that once installed, they cannot be removed. They also have the added benefit of stopping someone from repairing a blown fuse by putting a penny under the blown fuse, an old practice. It is very common to see overfused circuits on older fuse panel installations. The inspector needs to remember that, in most cases, the installation was designed to supply a relatively small number of circuits with relatively few receptacles. That would have been fine for the average family's needs in the 1950s and 1960s, but that's now exceeded by modern demands. Several types of fuses are available. Some blow very quickly, while others are designed to cope with short, extra startup loads associated with electric motors. These will blow after a short time if the amperage draw does not revert to normal levels. Inspecting fuse panels. There are two major problems with inspecting older fuse panels. First, check the main fuse amperages. The blocks have to be pulled out, which shuts off all power to the home. The second issue is that these panels tend to be unsuitable for modern, high amperage demands, and they tend to exhibit double taps and overfusing. Pay special attention to the following questions during an inspection. What is the main fuse rating? Are there double taps? Does the rating of the fuse match the conductors? Are the fuses updated to S-type? Is there any sign of the conductors overheating?